Hi, this is Jonathan Gardner, and one of my viewers asked me on Discord, he says, what should I learn to get started with machine learning? Like what should my background be? What kind of topics should I study before I study machine learning? And as you are aware, unless you're living under a rock, machine learning is the current hot topic. It's the thing that you can do to get paid lots and lots of money in the programming industry. And there's lots of videos and tutorials online, and people making claims like, oh, you can just follow this series or do this or do that, and you'll be able to learn machine learning. The machine learning isn't really a new concept. It's kind of derived from what we might have called data science a few years back. Even before then, we'd call it just statistics. Somebody once told me, he said that statistics is what you do on a piece of paper, data science is what you do with a single database, and machine learning is what you do with multiple computers, right? So anyway, I'm going to give you a general roadmap of what to do in order to learn machine learning. So I'm going to try to elaborate not too much on these, but give you kind of a hint on why they're important. So first, you need to learn to program. Next, you should learn how relational databases work. RDBMSs work. Next, you should learn everything you can about hardware. And after that, you should study how the internet works. And after that, you should learn statistics. And then finally, you can learn machine learning. This is kind of the background you need. And this is a huge order. I don't expect kids in college to really appreciate what machine learning is. Even grad students that go straight from their undergrad degree to graduate school, you're going to be doing something that approaches what machine learning is, but you're really just scratching the surface. It takes a lot of experience to really appreciate the science of machine learning and how it works. So about programming, thankfully today Python is pretty much the global standard for machine learning. It's rapidly becoming like the language everybody needs to know to do machine learning, which is great. It didn't used to be that way, but I think Python's a pretty good choice. It's flexible, it's easy to master, it's powerful. And as you know, I'm doing this video series on Python. This is part of that video series. The reason why I'm focusing on the details of how Python works and taking you down to a level that typical tutorials don't is because it's really important as a machine learning expert to understand the ins and outs of the language. The analogy is that programming languages they're unlocking the power of the computer, and so it's a very powerful tool, like a loaded gun, right? And if you have a loaded gun and you don't know how to use it, you're going to end up hurting someone, maybe yourself, maybe someone else. So learn how programming really works, learn the ins and outs of it, become a master at programming, and don't skimp on studying programming. If you don't like programming, you're probably not going to like machine learning. Okay. There is an art to it, there's a science to it, and all those things. Okay, relational databases. So I think this surprised him. He's like, what? Why should I learn that? So when I first found my first database at my first real job, I fell in love with it immediately. I've always dreamed of being games, writing video games and stuff like that. Everybody wants to write video games, right? But when I understood what the database was actually doing, I realized how important a role it played in the business and how much information, how much technology is packed into that single piece of software. So I learned PostgreSQL in detail. I gravitated to that early on. We're talking like the 2000s. 2000, 2001 is when I first started discovering databases. And the modern databases have evolved quite a bit from the databases in the 80s when they first started to become popular. And another thing to keep track is that since the 80s, there have been numerous fads that have come and gone. And the most recent fad that you probably heard of was the NoSQL movement, right? I think it's safe to say that the NoSQL movement is pretty much passé now. It's a fad that's come and gone, and the databases that were introduced to as a response to the NoSQL movement are now pretty much regarded as and I'm going to say this and people are going to complain, but they're pretty much unsuitable for any task. They're just not useful. There is a couple things that came out of it that were useful for very specific niche processes, but even then, when you introduce them into your stack, you're introducing problems that didn't exist if you were just relying on databases. So the NoSQL era, another joke is that people who understood PostgreSQL, who were using PostgreSQL, kind of like were puzzled by the NoSQL movement. They didn't understand why it was so popular. But you have to understand that at the time that NoSQL started, MySQL was super popular. MySQL has some idiosyncrasies and some problems that makes it very unsuitable as a database. So if you're using MySQL and if you've heard of PostgreSQL, I encourage you to learn PostgreSQL and get off of MySQL. I'm going to save you a lot of time and money by recommending that. Anyway, what do I mean by learning how the RDB messes work? So fundamentally, a database has at its core algorithms for how to store data and how to efficiently retrieve that data. Also within that are things like transactions. So we have transactions, we have storage, and we have retrieval. Efficient storage and efficient retrieval. And you cannot underestimate the value of having transactions. When you have a proper serialized transactional layer, then a whole bunch of programming problems just disappear. And you don't even need to think about them because of that. Storage and retrieval is a very difficult problem. It's very difficult to do it efficiently and effectively. Once you understand how relational databases translate the mathematics of the relational database to an actual working system, you're going to learn a ton about how data works, and that's going to save you a lot of work in the future when you work on your own machine learning problems, because you'll be able to reapply those techniques to your solutions. Hardware. Let's talk about hardware. So if you're an ML expert and you can't tell me about the latest NVIDIA chipsets and drivers, then you're not really an ML expert. You understand some of the algorithms, but you don't understand why those algorithms are important. Everything eventually has to run on the hardware. And I have seen people that are very intimately familiar with the details of the hardware be tremendously successful in ML, while people that don't understand the fundamentals, don't even recognize how memory works or how the GPUs, what they're actually doing. I've seen them struggle and just flounder. You can, if you want to, live in the shadow of people that have trailblazed the way and have figured out what hardware combinations work and work well. But if you really want to be in machine learning at the forefront, you're going to have to start learning about what the hardware does, how it actually works. Now, I made a video kind of giving you a model of how modern computers work. That model is the very basic, right? You need to build upon that and learn about all the new features that CPUs and GPUs have. You need to learn about transfer rates and all the new technologies that exist in terms of moving bits and bytes and calculating stuff on the hardware. Okay, learning about networking. So learning how the internet actually works. Things like DNS, TCP/IP. You need to know the difference between an A and an AAA record in DNS and things like that. TLS, SSL. All these things are super important. If you're fine working on just a single computer, you don't really need to pay too much attention to networking. But once you start trying to do algorithms that require multiple machines running in parallel, you need to understand what's really going on at the network level. You need to understand why it's important to know about the network topology and how switches and routers, what they're actually doing. Inevitably, the algorithms that you work, they're going to be constrained by the hardware that you deal with, the GPU, CPUs, the RAM, the data speeds and stuff like that, but particularly they're going to be constrained by the network and the network topology. So learning how that works, learning the details of how the internet works, they call this cloud computing nowadays. I really wish they just didn't use that word, because it's like a snake oil, basically. Many people are sold on the cloud as being the solution of their problem, but the cloud really is just the internet. And if you have a proper understanding of how the internet actually works, you don't call it the cloud, you just call it like networking and services and things like that. Okay, statistics. So I've never met a machine learning expert who said that they wish they didn't waste so much time learning statistics and math. Okay, I have met many who have cruised past others because they had that much better understanding of statistics. Right? So statistics seems to show up everywhere. It's ridiculous. So in my physics degree, as I started to leave college, getting ready for the career, my professor said, you might want to spend some time studying statistics. So I did. And it was useful. I was like, oh, that's pretty neat, My friend that got his PhD in math, when he left to go into the professional world, the professors there told him, like, you must master statistics. They're only going to ask you about statistics out there, and you have to become an expert in it. So he spent several months, studying statistics before he left as well. And indeed, he spent his entire career explaining statistics to people. So statistics is like, it's one of those fields that the mathematicians and the physicists and everybody, they kind of look at it and they're like, yeah, that's interesting. But it ends up being super useful in real life. So statistics is the king of applied math. It is truly used everywhere. Learn it, master it, think about the implications of it. You're going to learn to love it because you'll be using it all the time as a machine learning expert. And if you pick up any paper on machine learning, it's going to assume from the get-go that you have a very, very intimate knowledge of how statistics really work. And of course, finally, you learn machine learning. With the above, if you're applying these principles in your professional career, you're going to find that machine learning is basically what you've been doing this entire time. It's not going to be surprising. You're going to learn new terms. You may learn some new algorithms or new techniques. You may learn that some things you were doing were just special cases of a more general problem. But machine learning should be fairly natural and elegant to learn once you've done that. So I wish I could give you 10 tips to mastering machine learning in an afternoon, or just do this, you can't fail. But this advice doesn't work in the machine learning industry. It's constantly changing. It's what works today didn't work yesterday and won't work tomorrow. There's the story, and I'm kicking myself because I can't remember the name of this coach, but he's a famous basketball coach, I think, of a college basketball team. And he would recruit from the top high schools, the top players, the best of the best of the best. And they'd show up on that first day of practice. And then he would explain to them the importance of mastering the fundamentals of basketball. So he'd hold up a basketball and he'd say, this is a basketball, right? And so you, in your machine learning career, if you really want to master machine learning, you need to get back to the basics. You need to focus on the most fundamental aspects of computing. If you're one of these people that you have built your career in machine learning and you haven't mastered programming, you haven't learned how databases work, you don't understand hardware and networking, you can always go back and relearn those basics and build upon it to take your abilities to greater heights. So anyway, that's kind of my thoughts on how to get started with machine learning. This isn't the easy road, but this is the road that will get you where you need to go. Anyway, guys, I hope this helps. Take care, and bye-bye. Thank you for watching this video on the theory of Python by Real Physics. Be sure to subscribe and ring the bell, like and share this video. You can find me on Discord or support me on Patreon. Links are in the description below. Thank you so much. Have a great day. Bye-bye.